Hello student, we have to learn article electromagnetic induction and energy transfer. So to learn this article, we consider a loop of wire ABCD. So this is loop of wire ABCD. It is placed in uniform magnetic field B. So this is magnetic field B. So this is direction of the magnetic field. It is in the plane of the paper. Now we have to consider this loop. Let I give the name PQRS or ABCD. Any name you can give, PQRS. So when we pull this loop with speed or with velocity V in this direction, then magnetic flux associated with this loop changes and EMF is induced and the current is induced. So let I consider here the current is induced in this loop in clockwise direction. So I can show here the current. Okay. Then you know that current carrying conductor experiences some force in magnetic field. So I can consider here this side experiences force F1, this side experiences force F2 and this side experiences force F3. Now here the current through this segment PQ is toward this side and current through this segment SR is toward this side. Force experienced by both the segments is given by formula ILB sin theta. So here theta is 90 degree because this length of the conductor and the magnetic field is perpendicular. So the force is ILB. So current is same, I, length of both the segment are same. So and magnetic field is same. So they experiences same force. F2 and F3 both are same. So F2 and F3 cancel with each other. So they cancel with each other. So here F2 and F3 cancel with each other. So here only on this segment PS the force F1 is acting. So I can write the force acting on segment PS is, so I can write F1 is equal to ILB if I consider L is the length of this segment. So ILB is the force, equation number 1. Now when we pull this current, this wire loop, then EMF is induced, current is induced. That EMF induced, I can write here, EMF induced in loop, what PQRS is. So I can write EMF induced by formula E is equal to BLV. We already learned in the previous videos, EMF induced in a straight conductor when moved in uniform magnetic field is BLV. Hence, current, I can write here induced current. Current is I is equal to E by R. So I can consider E is the EMF induced and R is the resistance of this PS side. So we can write here BLV divided by R. So this is the induced current, equation number 2. Now, some mechanical work is done when we pull this current, when we pull this wire loop, some mechanical work is done and that work done we find out. Hence, work done, or I can directly write the rate at which work is done to pull this wire loop, or we can directly write down the power or the rate at which mechanical work is done. Means power basically. So formula is work by time So work is force into displacement. I consider displacement dx. So this coil is pulled with some distance dx divided by time dt. Then dx by dt is velocity. So F into V I can write for this power. Now here the formula of F is given by equation number 1. So I written F1 here. Let I write F1 also here. Take ILB. This velocity V as it is. In that I can substitute equation 2 also. I is BLV divided by R and into this LBV. So this B into B, B square. This L into L, L square. V into V, V square divided by R. So this is equation number 3. I hope this equation is visible here. Take it. So B square, L square, V square. This is a mechanical power. Similar manner, we can find out when this thermal power also here. Also, thermal power is, because when current is passed through this conductor, then so here the conductor gets heated. So the thermal power we can find out here. So power is equal to I square R. So this is the formula of power. And we have a formula of I square. It is BLV divided by R into this R. This is bracket square. So we get B square, L square, V square divided by R square into this R. This R and 1R from R square get cancelled. So B square, L square, V square divided by R. So this is the thermal power. Equation number 4. Now you can see here from equation 3 and 4. You can see equation 3. This is equation 3. This is the rate at which mechanical work is done, and this is the rate at which the heat is produced in a conductor. So both the formulas are same here. So it means that whatever the mechanical work we are doing, that mechanical work is converted into the heat. So both the rate of work done are same, or both the powers are same. So therefore, we can conclude that here the energy is conserved. Means whatever the mechanical work we are doing to pull the coil, that mechanical work done is converted into heat. And because of that we get same formulas here. I hope everyone understood here this electromagnetic induction and energy transfer. Means here mechanical energy is transferred into the heat energy.